Hello, Math 151. Let's take a look at homework 2.5, number 24. Let me share a screen in here. I have it. Okay. So in this particular problem that an object is being shot up or hurled uh, onto the air, we do have that initial velocity is 105 feet per second, angle is pi over 3, and initial height is 5 feet. And we're supposed to find t such that y of t equals 0. So notice that y of t equals 0 when this object hits the ground, because in the beginning it's being shot up from the height of 5 feet. So let me go ahead and stop sharing. And okay. So if I'm going to go ahead and set y of t equal to 0 and use quadratic formula. The problem is telling me that y of t equals initial velocity v naught times sine of theta times t minus 16t to the second plus h naught. And of course, I'm going to set that equal to 0. So 0 equals v naught, we are given in this problem is 105. Once again, you may have a different number. What is sine of pi over 3 is square root of 3 over 2 times t minus 16t squared plus 5. And so here I have a, which is coefficient of t squared is negative 16. B is 105 root 3 divided by 2, and C equals 5. And if I use a quadratic formula, and I've already done that to make this video shorter, the numbers that I get are x equals negative, t equals negative 0.0544. Of course, I'm going to toss this part because I don't have negative t. And the other answer that I'm getting is t equals 5.73776. And that is the time that the object is hitting the ground. In other words, the height is 0. And the question is, let me go to the next page. The question is asking me, what does x of t, I'm going to say here is the total distance, the projectile travels horizontally. So let's go to part B of this question. Let me go to the next part. Part B is asking for V naught theta and H naught in part A. So in part A, we were given that V naught is 105 feet per second, H naught was 5, and theta was pi over 3. calculate dy dx and find t2 so that dy dx equals 0. So first thing that I need to do is to calculate dy dx. I know that y of t is given to me in this problem as v naught sine of theta times t minus 16t to the second plus h naught. So taking the derivative of y of t, I get dy dt equals v naught sine of theta minus 32t. Okay. So now I want to set this equal to 0 and solve. So set equals 0 and solve. Let me go ahead and go to the next page. Well, so I have 100 dy dt equals v naught, which is 105 times root 3 over 2 minus 32t. And so setting that equal to 0, I'm going to have 105 root 3 over 2 minus 32t equals to 0. So I have 32t equals 105 105 root 3 over 2. And so t equals, or approximately, I should say t approximately equals, put that in my calculator. Well, let me do one more step here and say this follows that t equals 1 over 32 times 105 root 3 divided by 2. And so t approximately equals 2.84164585.6. So the question is asking, what does x of t2 represent? Going to the next page, x of t2 represents the distance the projectile has traveled horizontally when it is at its maximum. Maximum height. Because notice that we took the derivative, we took dy dt, and we set it equal to 0. And dy dt has a perfectly horizontal tangent line at its maximum height. So part C, which is probably the longer part algebraically, is asking what initial velocity is needed. So find initial velocity so that the projectile at theta equals pi over 3 from height of 5 feet to go over a 44 foot high fence. So we want the y to equal to 44. So y of t, we want it to equal to 44. And the problem is saying that the fence is 320 feet away. So x of t equals 320 feet away. So now we know that x sub t is 320, y of sub t is 44, and replacing that, remember that we were given x of t equals v naught cosine of theta times t, and y of t equals v naught sine of theta times t minus 16 t squared plus h naught. So now I can exchange the x sub t here with 320, and y sub t is going to be 44. So I will have 320 equals v naught cosine of pi over 3 times t, and 44 equals v naught sine of pi over 3 times t minus 16t to the second plus 5. Now notice that I have two equations, two unknowns, okay? The t is unknown and the v naught is unknown. So from the first one, from 320 equals v naught cosine of pi over 3 times t. Well, what is cosine of pi over 3? I know cosine of pi over 3 is 1/2, so I can exchange that with 320 equals v naught times 1/2 times t. Multiplying both sides of this equation by 2, I get 640 equals v naught times t, and solving for t equals 640 over v naught. And notice now that I can take this and substitute it in here and in here and solve for it. So I'm going to go ahead and go to the next page. So I have 44 equals v naught root 3 over 2, 640 over v naught minus 16, 640 over v naught quantity squared plus 5. So I can subtract 5 from both sides, and I can also cancel this v naught. Continuing that, I have 39 equals, the 2 cancel 640, so I have 320 root 3 minus 16 times 640 squared. I already have the calculation is 655, 3600 over v naught squared. Okay, so now I can go ahead and solve this. Subtracting, rearranging, let me take this to the left-hand side, so I get 6553600 over v naught equals 320 root 3 minus 39. So now multiplying both sides of this equation, this is v naught squared. Multiplying both sides of this equation by LCD, in this case v naught squared, I will get 320 root 3 minus 39 times v naught squared equals 655, 3600. And so v naught squared equals, dividing both sides by coefficient of v naught squared, I get 12719.108. and taking square root of both sides, I get V naught equals plus and minus 112.77 90229. And of course, I'm going to toss the negative root because I cannot have negative initial velocity. Okay, I hope you find this helpful. Thank you.